Dear participant, good evening, all of you, and welcome back to the second session of ongoing one-week workshop on interdisciplinary computing in basic and applied sciences. Today, our resource person will be the same, and he will continue his session. So the thing is that today we upload some content so that you can do hands-on. All the content are available, and I hope that you have already downloaded in your system. If not, then the Google form link, Google Drive link is available in the group, and from that you can download the content for the today's session. And also, if possible for all of you, you can join this presentation through mobile and cover the content, and for the hands-on purpose, do all these things on your laptop or PC. So without any loss of time, I would like to invite our today's resource person, Dr. Ravi Kumar Panchal. uh, Dear sir, over to you, and welcome back in this session.
Okay, so am I audible to you all?
Yes, sir, you are audible. And
Okay.
also, dear participant, I request you to all, if you have any question during the session, please feel free to discuss or ask your query so that your doubts and the problems which you are facing, you can openly discuss. And this workshop will be valuable and useful only if you are covering the content, as well as if you have any challenge or any problem, you are covering parallel. Okay, and we are here to help you. And also for the yesterday's lecture, if you have any doubt, you can discuss. And now I would like to over the mic to Professor Ravi Kumar Panchal. Over to you, sir.
Okay, sir. Thank you, sir. Again, so let me again. First of all, let me share my screen, and I hope it is visible to all.
Yes, sir. Screen is visible.
Okay. So let us again open our Jupyter notebook. So I'm going to press the start menu. I'm writing the Jupyter notebook in my start menu, and I can see that this icon is appearing. Let me click on that icon, and immediately you can see my Jupyter notebook is now opening. So that part we have discussed yesterday. So first of all, if you have any uh, anything which needed to be discussed from the yesterday lecture, we can discuss it right now. Otherwise, we can jump to our today's discussion. Okay. So I hope there is no doubt today also. So first of all, let us start with some basics of Python modules, then Python packages and libraries. Okay. So let us discuss what we mean by Python modules. So Python module is nothing but collection of Python definitions. So those definition will contain some different operations. Okay. So first of all, let us first create our own module, and then we will discuss packages, and then we will immediately discuss those libraries. Okay. So how to create a module? Let me create one module which greets which performs two operations. First of all, it will greet with the user's name, and the other operation will be addition of two numbers. Okay, so I wanted to make my own module, which will be later on in order to avoid duplications or repeatedly define these definitions, or it yeah, and these modules will be work in background so that we just see our clear screen. unless and until we just import those modules. So I'm going to create these modules using these definitions. So I have written these two definitions, and we need to store that definition in one Python file. You can see that I already created one Python file, and this Python file contains these two definitions, and I have named it by my module. So in my module, these two definitions are stored. And in order to create one Python file, we are working with this IPython files. Okay, Jupyter notebooks. Now, in order to create one Python file, again we will go to this new and Python 3. Okay. Sorry, we will go to file menu, new and note and Python file. So you can see that immediately my this file with py extension is created. Okay, so I already created one module with my module name. Now let me import this module. So in order to import that module, I just write import my module. I'm compiling it. So now the definitions which we have created in my module file are ready to use. So let us use these definitions. So let us greet everyone. Okay, and let me add this 5 and 10. So as far as this, I just compile it. You can see that there is no output, and in order to have user defined output, we just need to use print command. So you can see that my two definitions are used now. Hello everyone. Okay, because we wanted to greet you all. Okay, and we wanted to add 5 and 10. So this is how our user defined modules are created. Now there are many built-in modules available in the Python, and the regarding mathematics operation, a popular module is math module. So in order to again import math module, and this math module is as far as this we install this Python, this math module will be already imported. So it is inbuilt library of Python. So here I have imported math module, and suppose we wanted to find the square root of say 16. So what I will do is I will write math dot square root of 16, and if I compile it, you can see that my square root 16 is now obtained. Again, in this math module, there is numerical value of pi is also stored. We can get it up to some decimal points. Then one another popular module is random. We just skip this. Now, in order to import those modules which are not inbuilt pre-installed with Python, in order to call them or install them, we will write pip install and that module name in the PowerShell. Yesterday we have discussed there are three types of Anaconda. If I write Anaconda in the start menu, you can see that there are three options. You can see that it is Anaconda PowerShell prompt and Anaconda prompt. So I can use any of this Anaconda prompt or PowerShell to import those modules. So let me import, sorry, let me install one library which is called Pandas. Okay, so for that, in order to install those external modules, packages, and libraries, you will use this command pip install. And let me install this pandas. So whenever I just hit enter, you can see that there is some ongoing process. In my machine, already these pandas are installed, and that is why this message is displayed. Otherwise, your computer will install the required libraries and files to install these pandas. Okay, so this is how we can install some libraries and modules. So what is module? Module is nothing but one Python file which contains some collection of definitions, and afterwards we can import use those definitions for desired task to perform desired task. Then it comes packages. Now what is packages? Packages a module is nothing but one single Python file which contains couple of definition. Then comes packages. Now package is nothing but collection of modules and one init file. So all these will create one package. Okay. So there are again many packages available for some different tasks. Then it comes libraries. Okay. Now what is library? Library is nothing but collection of modules and packages. Okay, so it will create one Python library. So there are some popular Python libraries for available for different tasks. And some of the popular libraries for data science and machine learning are NumPy, Pandas, Matplotlib, Seaborn, TensorFlow, SciPy, and so on. Also, there is one AstroPy also for astronomical to handle astronomical data. Okay, so today in today's lecture we are going to discuss three important libraries of this Python. First is NumPy, second is Pandas, and third is Matplotlib. So first of all, let us discuss our NumPy. So NumPy is nothing but is useful for handling numerical data, and it converts your data into n-dimensional array. So first of all, let us import our NumPy. Now we can simply import. Again, this NumPy library is inbuilt in many of these systems in which Python is installed. But if it is not installed, then we have to install those libraries using pip command. So let us import NumPy. Okay, so you can see that this NumPy is imported. Now it is tradition. In order to avoid this whole name, that is NumPy, we call these libraries using their nicknames or alias. So it is customary that we just use this NumPy with its nickname, which is NP. So we will import, rather than calling it NumPy, we will call it now NP, because this NumPy is is having 5 characters, and in this NP is having 2 characters. So that is why this is short name of NumPy. So now onwards, we will in immediately whenever we use NP, it will understand this Jupyter notebook will understand that we have imported or we are using this NumPy. So first of all, as we have discussed, this NumPy is using n-dimensional array. So what is dimension? First of all, what is dimension of array? So whenever we just create one single arrow, single row of data, that is called one dimensional array. Whenever we create one some sort of matrix, okay, we can say in other words we can say matrix of having some rows and columns, it is called two dimensional array. Now it is possible to have this in general n dimensional array. So what will be the behavior of three-dimensional array? So it will have some rows, columns, and it will those say, for example, m by n, m rows and n columns are repeated p times. So that in that case we have created p by m cross n array. So here we are going to create one dimensional array which contains zero. So for that, we just write np dot zeros, and I want 5 times 0, and that is why I have written 5. If I write 6 here, then I will get 6 zeros. So you can see that there is only one row, and that is why this is one dimensional array. Now let us create two dimensional array. That means it contains row as well as column. And again, I want three by some sort of 3 by 4 array which contains all zero entries. So for that, command is np dot zeros. So you can see that there are 3 rows and 4 columns. Now let us discuss this vocabulary of these dimensions and the related things. So dimension is the thing, but number of axes. So here you can see that there are 2 axes, and that is why this is called two-dimensional array. You can see that there is only one row, and that is why this is called one-dimensional array. Now, the number of axes is called rank. Now, here the term is conflict with the rank of matrix. It is not related to the rank of matrix. Okay, so that number of dimensions are called rank here. So here that rank of this array is 2, or dimension is 2. Now you can see that yes. Now next is shape of array. So you can see that there are 3 rows, four this columns, and that is why the shape of this array is 3 comma 4. And what is size? Size of number of elements in this array. So you can see that there are 3 rows, 4 columns, and that in total there are 12 elements, and that is why this is the size of this array is 12. So let us again create this 3 by 4 array, sorry, two-dimensional array of size 12, and its shape is 3 4. Okay, so let us ask this numpy, what is shape of this A? So you can see that shape of this A is 3 comma 4. Now let us ask what is dimension of A? So we can say that the dimension of this array, which is A, is 2. And let us discuss what is it. Let us ask what is size of this array. So it is 12. So this is all about creating an array. In particular, we have created two-dimensional array. Now let us create one three-dimensional array. So you can see that there are 3 blocks. Okay, we have created three-dimensional array. So first number represents number of blocks. Now each block is having 4 rows and 5 columns. You can see that we have created 3 blocks. For each block is having 4 rows and 5 columns. So in this way, we can create this three-dimensional array. We can create array of higher dimension also, but we just stop it here, and let us move forward. So let us again ask what is shape. So you can see that this chain now, so, the size dimension is 3, and its size is 60. Now let us ask what is type of some array. Okay, so let us ask what is type of this np dot zeros of 3 by 4. So it is n dimensional array. In general, it is n dimensional array. Similarly, we can create one two-dimensional array with all entries 1. So for that, we will write np dot ones, and we want 3 rows, 4 columns. Let us make it 5 rows, 5 columns. Now, again, it is possible to have one some say n dimensional array with same elements. So we want each entry to be 2. So for that, the command is np dot full. We have created. We wanted to create an array of size 3 4, which is we should have it each entry 2. Now let us make it 1.5. So you can see that each entry is 1.5 and size is 3 comma 4. This is how we can create one empty array, which is similar to this zeros. You can see that this empty array, it is 6.14 e raised to minus 304, 307. So it is roughly 0. So it is an array of the size 2 3, which is having all zeros entry. Okay. Now let me interrupt you. Uh, uh, we have shared. Is there any? Right. Today we have asked you to have your laptop as well as your mobile for hands-on practice. So let me just interrupt you, and after this, we just simultaneously do all these practices. Okay, so I just request you to all that to open Google Colab in your laptop. So you just for that you just write Google Colab in your Google, and immediately this kind of website will be open. Okay, Google dot research dot Google dot sorry Colab dot research dot Google.com. So you can see that this one window is open now. Now we will go to. I hope Dr. Mahelchan, have we shared those Jupyter notebooks with participants?
Yes, sir. Files has been shared with them.
Okay.
And again, I request to all the participant, dear participant, we have shared the Google Drive link, and in the day two contains all the files which are going to discuss in this session. So if you know to download, please download all these files so that hands-on session can be executed, and this will be more interactive and helpful for the beginners to clear their doubts.
Yes, thank you very much, sir. Now, I hope you have downloaded your files in your desktop. So, in this way, so I request you all to download those files in one of the folder on in your desktop. Okay. Then we will go to files. Now we will open notebook. We will go to open notebook and we will use this tab which is upload. Now we will go to browse and we will go to desktop. You can see that the files on my desktop are visible now. So I will choose this same presentation. Again, I request you all to have two devices. One is your laptop and the other is your mobile. In mobile, you can see this presentation, and in your laptop, you can do this hands-on practice. Okay, so I hope you all have opened this Google Colab and imported this file. So let me again import this file. What I need to do, I just go to Google Colab. I will open this file, sorry, this website. Then I will go to upload, browse. I will select where is my file, location where this file is located, and I will choose this file 3a numpy.ipynb, open, and immediately this file will be open in your system. Okay, so we will simultaneously मैं भी यहाँ पे वो जो है ये सभी चीजें करूंगा, और अब भी मैं आप सभी को रिक्वेस्ट करता हूँ कि यू जस्ट परफॉर्म दिस टास्क इन योर सिस्टम ऑल्सो. Okay, right. So now let us again create one two-dimensional array having user-defined elements. So I have created this array. This will create one user-defined array of dimension 2. Okay. My first row is containing these elements, that is 1, comma 2, 3, and 4. And the second row is containing these elements 10, 12, 20, 30, and 40. So as for immediately, if I compile it, it will give me this output. So one two-dimensional array has been created. Okay. Now let us play with this arrays. Now, yesterday we discussed range function. So, this arrange function in NumPy is similar to that range function which we have discussed yesterday. Okay, so this will create np.arrange 1 comma 5 will create one dimensional array having elements 1, 2, 3, 4. It will start from 1. It will end with a number immediately previous to this number, the second number. So it will start from 1 and end at 4. So you can see that I have created one dimensional array having these elements. Okay. Now you can see that in by default, this step size is 1. Now, in order to change this step size, uh, that can be done by putting some third entry. So you can see that one array of dimension 1 is created. It has started from 1 and it has step size 3. And since it is, we have asked it to stop at 4, and that is why it is not going beyond that number, which is 4. So let us increase this number. So it is giving me this one dimensional array having these elements. You can see that it is
Yes.
starting from 1. Yes. Is there any query or discussion? Okay. So it is started from 1. Our step size is 2. And that is why these elements are 1, 3, 5, 7, and 9. We can change this step size, this also. Okay. So it works also with floats. So it is not necessary that we should start with integers. Okay. So we can start with one, say 1.5. Okay, with step size 0.1. So you can see that this again, this is one dimensional array. So how to know that it is one dimensional array? So it contains only it start with only one square bracket. It ends with also one square bracket. So that is why this is one dimensional array. Now, this is also discussed. Right. Now, sometimes it happens that we need to split this interval 0 to 2 into some say equal parts. So, say for example, six equal parts. So, in order to or in place of using this arrange, in order to split that interval into equal parts, we will use this lean space. This is more convenient in place of arrange. So it will split this interval 0, comma 2 into six equal parts. So you can see that these elements are 0, 0.4, 0.8, and so on. Okay, so this is how we can convert it into or say n equal inter parts. Now I will just skip this topic. You can I have already said this notebook, which because this is again a huge notebook. It contains all very sorry many functions, and that is due to time limitation, we cannot discuss each and every function. But these are less important or they are obvious. I will skip those concepts in order to cover more important topics. So I will skip this also. Array data. This gives us a type of those data. Okay, whether it is integer, complex, or so on. Data buffer. This also we just skip. Reshaping array. This is all we also skip this. Reshape again. Yes, arithmetic operations. Now, the operation are similar to which we have done yesterday, those arithmetic operations. We have done these arithmetic operations to the for list, tuples, dictionaries, and so on. But if you recall, we have added two arrays, sorry, two lists. So what was happened there? Let me open that presentation, and we'll go to lists. Yes. So you can see that these are two lists, list 1 and list 2. And if I add these two lists, it will concatenate these two lists. But the things are different here in case of NumPy array. If I add these two arrays, it will add elements of respective indices. So it will add 14 and 5, Then it will add 23 and 4, 32 and 3, which is 35, 41 and 2, which is 43. And it will again create one array of this same dimension. Okay, so this is how this addition works in case of NumPy arrays. Okay, it is different. It is having similar syntax, but it performs different operations. So these are other operations regarding this NumPy array. This will subtract these elements. This will multiply these elements. This will divide. This will find remainders, module, and so on. Okay. Then we will skip this broadcasting. Yes, upscaling. Yes, conditional operator. Yes, mathematical and statistical functions available in NumPy. Okay. So I have created one NumPy array having these elements, and let us print this NumPy array. So this is my two-dimensional array, and I wanted to find mean of all data in this array. So for that, command is whatever this array is stored in variable, I will write that variable name, which is a, in this case, dot min and pair of round brackets blank. So this will give me mean of this data. Then there are other options, functions also, which is minimum, maximum of this array, sum, product, standard deviation, variation also. And due to time limitation, I have put this all these functions in one or these two physical lines using for loop. Yesterday, I wanted to cover these loops and conditional statements, but due to time limitation, unfortunately, we are not able to cover those topics. But you can explore by yourself, right? So this is you can see that this is minimum of this array, these elements. This is maximum is 12. Sum is 40.6. This is product. This is standard deviation and variance. Now, this is how we can reshape. Let me create one three-dimensional array of order, sorry, of type, sorry, of size 2, 3, 4. That means I'm having two blocks. Each block is having 3 rows and 4 columns. Now I've created this elements of this blocks from 1 to 15, so 1 to 24. Okay, since I have written 25 here, it is going to consider up to 24. So the elements are 1 to 24, and I have stored this array in C. Now let us see what is this x is 0. So x is 0 is nothing but my, sorry, okay, so sorry, it is not x is 0. Sum of x is 0. What is x is 0? So x is 0 is nothing but your blocks. So it is adding these blocks, this first block with second block. So you can see that this is sum of 1 and 13. This 16 is sum of 2 and 14. This 18 is a sum of 3 and 15, and so on. Okay, so now let us find sum of x is 1. So x is 0 is nothing but blocks, x is 1 is nothing but rows, and x is 2 is nothing but columns. So you can see that there is additions of these rows, elements of these rows. So you can see that it is addition of 1 plus 5 plus 9. So 9 plus 1, 10, and 15. So you can see that 15 is there. Then 2 plus 6 plus 10, which is 18, then 21, 24, and so on. So this data is regarding sum of these three rows. Next row is sum of these rows in second block. So there are other options also. We just keep this due to time limitation. Array indexes. This is how we have worked with those elements of string, list, and those tuples and so on. Okay, so this is how we can extract these elements. Again, it will start from this index will start from 0, and it will consider increment of 1. So this is zeroth element, this is first, second, third, and so on. And that order will be considered if we go from left to right. If we go right to left, then those number will be those index will be start from negative. So this is my last element, this is my second last element, and so on. This is second to fourth data of index, and so on. So this is how we have discussed this with slicing and extracting data of strings and so on. So we just keep this multi-dimensional array. Yes, we have seen glimpse of that. Higher dimensional, we just keep this. Yes, iteration. Yes. Now this is some sort of important to us. Linear algebra. Okay, so this NumPy has inbuilt operations regarding linear algebra. So, in order to use those operations for regarding linear algebra, it first of all, let us create one array, two-dimensional array. Now, in order to have transpose of this array, we just write this array name, which is M1, and by using this dot t, it will give me output of transpose of this array, two-dimensional array. Now, this NumPy will gives us transpose of only those arrays which are higher, which have dimension higher than or equal to 2. So this is one dimensional array, and if I wanted to find transpose of this, it is not possible because it works only for dimensions arrays with dimension more than greater than equal to 2. Now let's discuss matrix multiplication. So let us again create two arrays, NumPy arrays. Now we know that if you want to multiply A and B, so the number of columns and number of rows, the number of columns of first matrix and number of rows in second matrix should be same. Okay, and this thing we should be careful. Okay, you can see that there are five columns and 5 rows, and that is why this matrix multiplication is possible. And regarding matrix multiplication of these two matrices, we just use n1, that is our first matrix, dot n2. So it will perform matrix multiplication of these two matrices. So there are other yes. In order to have use those, in order to find eigenvalues, eigenvectors, and related quantities, we need to import these libraries from NumPy, sub library from NumPy. So we will import NumPy dot linear algebra. Okay, lineage. Okay, linear algebra as lineage. So this is one this uh, two-dimensional array. You can see that there are this is square matrix, some sort of square matrix, and this is its inverse. This is pseudo inverse. So this you can discuss, you can see, explore these options regarding linear algebra also. So we are done with this NumPy. Since we are going to discuss three important libraries, first is NumPy, second is Pandas, and third is Matplotlib. We are done with our first library, which is NumPy, and immediately we can discuss some. We can take some questions from regarding NumPy. How to include? Sorry, I just forgot to, how to include 10 also. I think this question is regarding those range arrange operation. Okay, so in order to include 10, we will write simply, if you wanted to consider 0 to say 10, we will write 0 comma 11, so it will include 10 also. Okay, is there any other question? Okay, so let us move towards our next library, which is Pandas. So let me close this NumPy, and I request you also to open your this file, which is 3C Pandas, in your Google Colab. Now, this Pandas is very much useful regarding data analysis. Okay, so it again works similar to those NumPy. So it also works as n-dimensional array. But in this one-dimensional array is called series, and two-dimensional array is called data frame. And in general, n-dimensional data is part of data structures. Okay, so there are facilities. What are the facilities available in this NumPy library? So it has a facility regarding data cleaning. That means handling missing data, filtering that, transformation, data alignment, splitting data, merging and joining, time series, and so on. Okay, so let us explore this pandas. So in order to use this panda, first of all, these pandas are not included in your Python libraries. Okay, so we have to import this pandas library, and we need to install those pandas library. So for that, we will go to start menu. We will write Anaconda. You can see that there are three options. Two are regarding Anaconda prompt and Anaconda PowerShell prompt. We can use any of this. Let me use this Anaconda prompt. And in your machine, those who are using Jupyter Notebook, they are required to install this pandas. But those who are using Google Colab, they are not required to install these pandas, because it is already there. This library is already there in Google Colab. So there is no need to install pandas, but it is required to import pandas, whether we are working with Google Colab or Jupyter Notebook. So first of all, install this pandas. So for that, the command is pip install pandas. You can see that there is some process is going on, and if you're in your computer, these pandas are not installed, it will install pandas. Since in my system, if these pandas are also is already installed, it is showing me this message. So this is how we can install pandas, and this process is only one time in your system. After that, you can immediately, after installing those pandas, you can immediately import pandas. So in order to import pandas, we can write import pandas as, we will use nickname of pandas as PD. So we'll import pandas as PD. Now let us check whether this pandas is installed in this machine or not. And if it is already installed in this machine, let us check its version. So it is by running this command, it is showing me that that version is 2.2.2. So that means pandas are already installed in my system and its version is 2.2.2. Now let us discuss data structures and basic operations. So we have discussed that there are two mainly major data structures. First is series, which is one-dimensional array, or we can say that one-dimensional data structure. And second is data frame, which is two-dimensional data structure. And there are other also, but these are more important for us. So let us deal with series, which is one-dimensional data structure. So we can create series from list. So let us you can see that I have created one list. Let us recall that we can create list using a pair of square brackets and their element should be separated by comma. So this is one list and it is stored in my this variable which is data. Now, in order to convert it into series, that command is pd. Okay, since we have given nickname pandas as pd, we will use pd dot series and data, and let us print what is therein. Okay, let us store it into some uh, series, and let us see what is there in this series 1. So you can see that this list has been converted into series. Now, what is this? This elements on left hand side are nothing but indices. They are not elements of the series. Let us again recall these are not elements of the series, but they are indices of the elements. That means this is first element, 10 is first element of the series, 20 is second element, 30 is third element, and so on. Okay, so this is how we have created one series from list. Now let us create a series from dictionary. So I have stored this dictionary into data, and again using the same command, that is pd dot series in bracket data, it will convert this dictionary into series. So this time this is my series. Now what are these? Again, those are dictionaries. Sorry, those are see what indices. Yes, these are indices of these elements. Then scalar values. So let us create one series having the same values of each element. Now let us access our data from this series. Okay, so this is my last series. I have named all the series same name. I call all as series. Okay, but it will remember whatever I have compiled at the end. So in last, I have compiled this part, this series, and that is why right now my series is this, which is having all the elements same. But this is less preferred because it is having same data, and that is why let us consider this series. Okay, so the elements are first element is 10, 20, 30, 40, and 50. So this is my elements of the series. Okay. Now let us access the elements. This is first element, this is second, third, and so on. Okay. Now what is regarding series A? So for that, let me compile this. So A 10 is regarding A, 20 is regarding B, 30 is regarding C. So this will gives us what is associated with this index or label A. Okay. Now this is slicing, which is similar to that previous operation which we have done yesterday. Then operations vectorize. Let us keep this. Okay, let us perform it immediately. This is my series, and this will add 10 to each element of the series. So you can see that these are elements, our original elements, and in all the elements, these are added. 10 is added. Okay. Now, element-wise operation. So this operation is similar to that operation which we have done regarding numpy arrays. Okay, so I have considered these two series. First series is having these elements 1, 2, 3. The second series is having these elements 4, 5, 6. Okay, and let me print what are the elements. So you can see that the elements of series 1 are 1, 2, 3. The elements of second series are 4, 5, 6. And let us add them element index wise. So let I wanted to add 1 and 4, 2 and 5, 3 and 6. And for that, we can use addition of series 1 and series 2. So you can see that 4 plus 1 is 5, then 7, and 3 plus 6 is 9. Yes. Now let us create one series using numpy elements. Okay. So for that, first of all, we have to import numpy and let us create this series from this list, and we have stored it into series. So if I print what is series, you can see that the elements are 1, 2, 3, 4, 5. Now we wanted to find exponential of all the elements. That means e raised to 1, then e raised to 2, e raised to 3, e raised to 4, and e raised to 5. So for that, we have to import this numpy array. Sorry, numpy library, right? So I have already imported this numpy as np, and I'm using this np dot exp. Exp is regarding exponential function of this series. So you can see that this is output of e raised to 1, this is output of e raised to 2, this is e raised to 3, and so on. So this is how we can use multiple libraries at the same time. Now, handling missing data. Okay, this is very, very important regarding data analysis. It may happen that sometimes it may happen that we are working with a large data. Say, for example, it is having say 6,000 data, and it is having say 5 columns. So 5 columns and 6,000 rows, and we wanted to eliminate a row which is having no data. Let us consider that, say for example, only 5 rows are having no data. So in order to work with them, with those data, we have to, first of all, we have to deal with those null data. So this is how we can use or handle those null data. So here I have created only one dimensional array, that is series, and you can see that this one element is null. Okay, so you can see that it is showing me that, I'm checking that whether there is null data available in this array or not. Okay, so it is telling me that first data is not null, and that is why it is giving me false. This is also false, but you can see that as this third data is null, it is showing me that yes, your third data is missing. It is null. Now, either we can remove some rows regarding those null data, or alternatively we can fill it using zero or hypothetically other numbers also. Okay, so for example, if you wanted to replace this null data by zero, for that command is dot fill na by zero. So this will replace my null data by zero. So you can see that my this array, sorry, my series is this. It is having 1, 2 null data and 4. And here I have replaced this null data by 0 using the dot fill na command. Uh, at the same time, we can drop this element from the data. You can see that this first data is there, second data is there, but that null data is not there. So in order to drop that data, that command is dot drop na. Now, these are other attributes and methods regarding series. So first of all, let us find indices of the series. Okay, so it has started from 0, it stop at 4, and it has step to size 1. So what are the values? So the values are 1, 2, null, and 4. Let us find mean of those data. So we can say that this is mean, this is maximum, this is minimum. Okay. Now it is possible to assign 8 user-defined indices regarding given data. So you can see that these are my data. I will consider, and this time I'm going to consider two series. One series is having this data 1, 2, 3. The other series is having this data 4, 5, 6. Right. Now, in order to assign this first data as index A, I will write in this way. So this will assign the second data is index B, and this will assign C as C to this third data. And this is how we can assign this BCD to this 4, 5, 6. Okay. And let us print, first of all, let us print series 1. So you can see that now my indices are changed. Okay. They are not 0, 1, 2. They are ABC now regarding series 1, and regarding series 2, my indices are BCD, and this is how we can add them. So this is overview of one-dimensional NumPy data frame, which is series. Now let's discuss two-dimensional data frame. So we can create data frame using dictionary. So I have already created one dictionary, and I have stored this dictionary into data. and let me print what is data. So we can see that it is this dictionary. Okay. So this right now it is in dictionary. Now let us convert it into data frame, that is two-dimensional null pair. Sorry, this pandas data strings. So you can see that this dictionary is converted into data frame. It is also possible to convert this data frame, sorry, dictionary, collection of dictionary to data frames. So here you can see that in place of uh, having only one dictionary, I am having collection of dictionaries. Okay, these are collection of three different dictionaries. So let me print what is data. Okay, so you can see that this is first dictionary, this is second dictionary, and this is third dictionary. And this is how we can convert this dictionary, which is named as data, into data frame using this dot data frame command. And these are other options to convert list of list into the data frame. The CSV, yes, this is now very much important. I have this CSV file, and let me show you in this Excel software. So you can see that this is my collection of data. It is very huge. It is collection of 241 data, not 241. It is collection of 240 data. This first row is regarding their name. So first data is having data of temperature, luminosity. That means this is collection of this is data regarding stars, different stars. Okay, these stars are having different temperatures, luminosity. That means how bright these stars are, the radius, absolute magnitude, then star type. They are having 0, 1, 2, and so on. Star colors, they are of different colors. This is red. This much stars are having red color, then blue, white color, and so on. And then spectra class. So this data is stored in this file, this CSV file, which is clean start data. And let us now play with this data. So in order to first import this data, we will use this dot read underscore CSV file, CSV command. And in pair of round brackets, we will write this file name in pair of inverted commas. So you can see that, and if I print this DF, I have stored this data into DF, okay, data frame. It is short form of data frame. So this is how it prints data from this data frame. So you can see that these are regarding several columns regarding temperature. First is regarding temperature, then the second is regarding luminosity, radius, and so on. But you can see that there are two dots. Okay, so you can see that this is first row, second, third, fourth, and fifth, and these are last rows, and these rows are missing. But right now they are not visible to us, but all the data is stored or imported into this Python file, right? So these are one, two, three, four rows, sorry, four columns, and these are other three columns. So this data is having 240 rows and 7 columns, and these are their indices. Okay, they are not part of data. Let us again recall. These indices are not part of data, but they are say labels of data, indices. Now, in order, yes. So this is how we can import data from CSV file. This is how we can import data from JSON file, JavaScript. Okay, this data is regarding JavaScript. So this is also one collection which is JSON. I'm not having any software. Okay, but this data are available in this data.json file. So again,
Excuse me, sir.
this yes.
Sir, how to upload this CSV file in Colab, Google Colab?
Okay, okay,
So,
okay.
yes,
Yes, yes.
yes,
So
kindly please
let
tell
me
me.
first open this Google Colab. So first of all, right. So you are dealing with this Python notebook, Jupyter notebook, which is 3C pandas. So let me first import this Jupyter notebook. So I will go to file and then I will go to open, upload, browse. These files are available in desktop, Python, and you can see that it is this 3C pandas. Open. So you can see that immediately that Jupyter Notebook will be open in this Google Colab. Right. Now we wanted to import this CSV file in Google Colab. So again, we will go to File, and then we will go to Open Notebook. We will go to Open Upload, Browse, and then we will select this CSV file. Okay, sorry. We'll go to file and not okay. This option will not work, but we have to go. We have to click on these files, right? Then you can see this option, which is upload to session storage. Now I can select this CSV file. It is giving me this warning that though this is important, this file is important in the Google Colab. I should this data should be this file should be saved somewhere else. Okay, you can see that this data, this CSV file is important now, right? And now this will work. Okay, let me first run this import panda as PD. Now let us scroll down and this is yes. So let us import this CSV file. So for that command is pd dot read underscore CSV. I will write my file name, which is clean start data dot CSV file, and let me print it. So this is my data.
Okay, thank you so much, sir. Thank you.
Welcome. So let me close this Google Colab notebook. Right. So this is also possible to import data from JSON file. Now let us use this some NumPy features as well as pandas features regarding data structures, data frame. So first of all, I have to import NumPy, and I'm calling. I'm giving it nickname as NP. So these are my data frames. I've stored it into data. So this is my data frame. Now, uh, right now, this data frame, you can see that. there are three columns, but they do not have any name. So let us name these columns as first is regarding name, second is regarding age, and third is regarding city. This we can do if our data do not have any title regarding particular columns. So let us name these columns, and you can see that now their titles are there. These are titles of this particular columns. Yes. Now viewing or accessing data. Okay, this we have already done. Yes. So, but again, let us import this data. So this is our data from the JSON file. Mm, Now accessing initial data. Okay. Suppose sometimes it may happen that we don't want to access all the data. We want only uh, initial data. Say initial five rows. So for that command is df. Okay, df is since why we are using df, because we have stored this data in df data frame, right? So df dot head. So it will give display initial five rows. Suppose I want initial 10 rows, so I will write 10 here. So these are initial 10 data. Similarly, this command is regarding last five rows. Okay, so by default it will give display last five rows. Let us make it 10 in order to have or access last 10 rows. Now let us access some particular data from columns. So let us explore only column duration only. So this is how we can access some of the columns from the data. So some or many. That, for example, pulse and max pulse. So these two columns are important. Then accessing raw data. Okay, this is regarding this string. Okay, we just keep this. This is regarding slicing, conditional selection, basic data operation, adding column. Huh. Okay. Before we proceed, let us take some 5 to 10 minutes break. Is it okay? Because we are dealing with so many functions, and we are dealing with so many data. So in order to have have some relaxation, let us take some 5 minute break. Professor Mahelchan, is it
Yes,
okay?
sir. Dear participant, there is a small break for 5 minutes, and we will resume the meeting exactly after 5 minutes.
Yes.
So please stay connected. Thank you.
Okay, so first of all, let us take some of the questions. The first question is, if data is n dimension, then how to find matrix? Right. So, for example, and I think this question is regarding NumPy. Okay. So, you can see that this. My can you tell me that whether my screen is visible or not? Hello?
Yes, sir. Screen is visible.
Yes. Okay. So this is two-dimensional array, right? So it is having this four columns and three rows. So this is two-dimensional array, which is similar to matrix. But this three-dimensional array will not be in the form of it will not be in the form of matrix, but it will be collection of matrices. This, right? So we can see that it is some sort of creating layers. So this block is first layer, then this second block is second layer, then we can put this third block into third layer. Okay, so this is how we can visualize this three-dimensional array. And if we consider more the array of say higher dimension, it is not possible to visualize them. Okay, so they will be fall into abstract category. I hope I have justified this question. Okay, let us consider this second question. Okay, is there any other question? Yes. So we just proceed to our next topic. Data frame operations. Adding columns. Yes. So you can see that I have created one data frame from this list. Okay, collection of list. And let us bring this data. So you can see that there are three columns. Now, let us add some and another column. So for that, the command is dot data frame data, and these are okay. These are column names which we already have discussed. Now, in this data frame, this is how we can add an another column which contains this data of country, and these are the elements. So these countries are USA. Regarding second person, that is that data regarding country is not available. This is data regarding third person, which is his country is USA, right? So this is how we can add another column regarding some data. Okay. Now let us remove a column from this data, and let us remove this data regarding country. So if I consider x is equal to 1, it will remove this column. And if I consider x is equal to 0, it will remove this row. So let us remove column having name country. So you can see that this column country is removed now. Uh, Now, handling this missing data is similar to which we have discussed regarding one-dimensional data frame, which is series. Okay, it is similar to that. So we just keep this grouping data. Uh, let's keep this. because we have removed this that column, and that is why we are getting this error. Otherwise, once you just add this column regarding country, there will be no problem. Okay. Is there any question? I think mic of some of the participant is on. Mr. Chinu, Goel, is there any question? Right. Merging data frames. Yes. So we are having two data frames. This is first. This is second. Now this merge data frame, and for that command is dot merge df1 df2. This is sufficient, and these are this is regarding other options. So this will merge data from these two data frames. Then concatenating. This is merging data. This is concatenating data. Okay, so this will add or combine data from these two different data frames. Now let us discuss one interesting example. Since I'm working in the theory of relativity, I consider one observational data of stars. So, and it is stored, the data is stored in this file, this CSV file, which is clean star data. So this data consists of 240 rows. There are total seven columns, which is six having some features, and one is regarding target column. The first column is regarding absolute temperature. Second column is regarding luminosity. Then third is radius, magnitude, color of stars, spectral class, and star type. Okay. And what is L0? L0 is nothing but average luminosity of sun. R0 is the average radius of sun. Okay, then what is star color? Let's skip this. Uh, Now, regarding this spectrum class, this zero is regarding brown dwarf, one is regarding red dwarf, two is regarding white dwarf, and so on. So let us import this CSV file in DF, and this is my data from the CSV file. So you can see that these are data from this data frame, sorry, CSV file. Now, you can see that this many data are skipped, or it is not directly visible to us. They are imported in this Jupyter notebook, but still we are not able to see all the data. So in order to see all the data, that command is to underscore string df dot to underscore string and empty pair of round brackets. So you can see that my all data are visible now. Now, since I have zoom in order to have better visibility, this data are misbehaving. But if your aspect ratio and zooming level is correct, you will see proper data. Okay, so this is my whole data. You can see that it is very large. So let us check what is data type. So it is the data type is in regarding pandas library, and the data type is data frame. Now let us ask it to describe regarding this data. So there are 240 data regarding these different columns. Mean of temperature is this much, luminosity is this much, and other means are available. Now, these are standard deviation of temperature, this is standard deviation of luminosity, and so on. This is minimum of temperature, this is minimum of luminosity, this is minimum of radius, and so on. Then, what is 25 percentage? This is not percentage, this is percentile. So, this 25 percentile data overall from this temperature is this much regarding temperature and so on. Okay, this is for 50 percentile, 75 percentile, and this is maximum of temperature. It is 40,000. This is maximum luminosity and so on. So this is how we can have some description of data. This we already have discussed. This we already have discussed. Let us explore first 10 data from this file. Now, yes. Now you can see that you can see this radius data. You can see that all these data are not sorted. Okay, they are random numbers. So let us sort this data regarding radius. So for that, that command is dot. Since I would stored these values in df dot sort values into in pair of round brackets. I will write radius. Make sure that you have given that exact name of that column. If I write only radius, if I keep writing this, it will give me error. Okay, so we have to write that whole name, and you can see that my data is now sorry. Yes, uh, this file run without any error, and let us what I have done. I have stored this data into df sorted underscore er, and let me print it. So you can see that this data is sorted regarding radius in increasing order. Now, in order to sort it in according to decreasing order, so what we have to done, the command is same, but after the at the end, after this call comma, we have to write ascending is equal to false. So in order to this will sort our data into decreasing order. So you can see that my data is in decreasing order regarding this time I have asked to sort it for luminosity, and the other associated data will not be changed. So that means this radius 1252.00, yes, this is regarding this luminosity. And this head we have discussed, tail is discussed, drop. Yes, let us drop some of the columns from the data. That is absolute magnitude. Let us drop it. So you can see that my 7 columns are not 7. Now this absolute magnitude column is dropped now. And let us remember that I have stored this data into another data frame, which is df dot drop list. My original data frame is as it is. So if I ask it to print the df, the data will be the same. So print df. You can see that there are 7 columns available in df, but in this there are 6 columns. So in this drop that data frame. We have six drop that particular column. We can describe it. Now let us locate some of the data from index number 6, index number 7, index number 14. So for that, command is loc regarding location. In pair of two square brackets, we will write whatever index data regarding particular index we want. So this is my data. So this is data regarding all the columns. Let us explore data regarding some of the columns. Then addition of two columns. This you can explore by yourself. I just skip this. Again, I skip this. I skip. Yes, this is important. Why data profiling? This is not part of pandas, but I thought it is discussing this why data profiling. So first of all, as we have installed pandas previously, we have to install why data profiling. So again, we will go to what is called Anaconda prompt. So this is my Anaconda prompt, and we have to pip install y data profiling. So since I already have installed this y data profiling, this message is displayed. Otherwise, in your system, this y data profile will be installed. Let us import my numpy and pandas, and let us again read this
Some of the
CSV file.
participant has unmute mic.
Yeah.
Uh, Dear participant, please keep muted if not required. Yes. Thank you. Thank you, sir. Please carry on.
Yes. So this is my data again. Now these are some of the options to install this Y data profiling in various operating systems. So let us import this Y data profiling. Import profile report. Okay, and I have compiled this course. There is some difficulty in this data itself, and that is why we are getting some this display error. Otherwise, but it doesn't impact on our analysis, and that is why we just ignored this error. Okay. So you can see that the number of variables are seven. Number of observations are, see that this will gives us some interesting analysis. Okay, you can see that the number of observations are this. Missing cell, there are no missing cells. Percentage of missing cells. Duplicate rows, there is no duplicate rows. Uh, and that is why that percentage is zero. Alerts. This has this data has 16.7 percentage zeros, okay, which is of star types. These zeros are available because we have called different stars as according we have given that data regarding that types, reproduction and so on. Then we will go to this variable option. Let us select temperature. You can see that there are 28 distinct temperature data. 95% data are distinct. Missing is zero, and this is this bar chart of regarding temperature. This is regarding luminosity, and these are their analysis. This is minimum. This is maximum. Zeros are zero. There is no zero negative. There is no negative data. Memory. This is its memory size, radius, more details. So these are some statistical analysis. Minimum is this, fifth percentile is this, Q, this is Q1, this is median, and so on. Okay, this is mean, this is its histogram regarding what data? Yes, radius. Column values, extreme values. Okay, so these are some of the extreme values. These are 10 minimum values. These are 10 maximum values. Let's discuss interaction of different parameters, interaction of temperature and star type. Okay, you can see that the temperature of the star type 0 is less than 5,000. Temperature of this first type is near to 5,000. Temperature of the star type 2 is more than 5,000, but it is less than 30,000. Okay, this much analysis is done using only the code of only three lines. Let us see the relation between temperature and luminosity. So we can do this kind of analysis also. This is the relationship between temperature and radius. Let's discuss different relationship between luminosity and star type, radius. So this is very important regarding analysis. So this is all about these pandas. This is just overview, not all, not everything. We have not covered everything. You can explore the other options in this website. There is lot of information provided regarding pandas. You can explore by yourself. So let us quickly go to our next topic, which is matplotlib. So we are going to cover this much topics. We will not cover all the topics in details. Will due to limitation of time because it is already 8:53. We only 7 minutes. So we are going to complete it within 7 minutes. So first of all, regarding plotting graph, that library is matplotlib. So let us import matplotlib. Sorry. Now this command is in some of the IDs. Those graphs will be displayed uh, externally. Okay, they will pop up. Now, in order to have this inline graphs, this is the command. Now, there are this library has sub library. This matplotlib has one sub library which is pyplot. So let us import this pyplot, matplotlib.pyplot as plt, and this is command to plot a graph of this data. This data is regarding y, and it will automatically consider the values of x starting from 0. So this y is value of y is regarding 0, x is equal to 0. Regarding x is equal to 1, it is y is equal to 2, and so on. So this will create my plot. This plt dot plot of this data will create my plot, and plt dot show will give me output of this graph. Okay. Now, it is also possible to have customized values of x and corresponding values of y. So I have considered the values of x as -3, -2, 5, and 0. And these are the corresponding values of y. Okay, so regarding x is equal to -3, value of y is 1. Regarding -2, it is 6, and so on. So using the same similar that command lines, we can draw this plot of this data. So this is regarding x, this is regarding y. Alternatively, we can do this in this way also. So let us store this list in x. Let us store this another list in y, and this is x comma y. So it performs the same task, but the terminology writing pattern is different. Okay. Now here you can see that axis range is from 0 to 6 and 0 to
Hmm.
sorry -3 to
Hello.
yes,
Hello.
yes madam, yes.
Sir, I'm asking if data is n-dimensional or more than n, then how to make a matrix and how to satisfy the definitions of matrix and the operation of matrix.
Madam, that n-dimensional data, that means more higher than three-dimensional data will cannot
Mhm.
be visualized geometrically. We can visualize only three-dimensional data. That means
In,
in
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 the linear algebra, we can solve higher dimensional data.
okay. As we have discussed previously, that there is some conflict of terminologies. Here, the dimension of numpy array is different than dimension of that matrix.
Okay.
These two are different terminologies. There, the dimension is regarding that rank nullity, but here that dimension means if we have one dimensional array, that means it is having only one row. If
Yeah.
the dimension of numpy array is 2, that means it is having one some rows and columns.
Okay.
Okay, and
Okay, sir.
if our dimension is greater than 2, that means it is having those blocks of some rows and columns.
Then we solve this matrix by block matrix operation.
Uh, Madam, again, let me make it clear that uh, that dimension has nothing to do with the dimension of array. Let
Okay.
this is three-dimensional array. Okay,
Yeah.
you can see that it is three blocks of this matrices.
Okay.
Okay, so we can consider it is this is a first layer of this matrix, then this is second layer, and this is third layer.
Okay.
Okay, if we consider four-dimensional array, that means six. So it is giving me this much blocks.
Okay.
Okay, so it has nothing to do with dimension of matrix.
Okay.
Okay, okay.
Okay. Thank you, sir.
Yes, welcome. Right. So we are discussing this graph. Right. Now, we have considered discrete data regarding x values. Now, let us consider some many values. Okay. Say, for example, 500 values between -2 to 2 regarding x. So, in order to have that continuous smooth graph, okay. So, in order to do that, in order to have 500 entries from -2 to 2, Regarding x, I have used this numpy. So I have imported numpy as np. Regarding this lane space, which we have previously seen regarding numpy, we are converting this, creating 500 data between -2 to 2, and I'm considering y is equal to x square. And using this plot, plt dot plot xy command, and it will create one graph of y versus this x. Okay. And in order to avoid this message, we have to use this plt dot show. So you can see that that message is now removed. So using this plt dot plot and plt dot show, we can create graphs of some functions using this discrete data. Now, this data does not, this graph does not contain any grid. So let us put some grid lines. So for that, the command is plt.grid. So you can see that these grid lines are visible. It is also possible to label this axis using this x label and y label command. So you can see that the label of, this is label of my y-axis, this is label of my x-axis, line style and colors. Let me just keep this. Yes. And now you can see that I have created one data regarding x, this data regarding y, and I'm, first of all, let me compile it. So you can see that this graph is plotted. Now, in order to make it these lines of different color, we can use this G regarding color G. If we wanted to make it dotted line, we have to use this double slash, sorry, dash. So it is converted into, it is using this dash lines. Then these are different options regarding plot. You can explore it by yourself. Let us skip this. Let us again skip this. Saving figure. Yes, this is important. Now it is also possible to save these figures uh, in some different formats. I have using this dot save fig command, I have stored this graph of x square versus this y versus or y is equal to x square in this png file. You can see that in my this same folder, this png file must be created. Yes, this is my png file. Now, what is the beauty of png file? It has transparent background. So it just perfectly match with your with your layout, and this is the advantage of uh, having PNG file. Okay, so this is how we can create subplots. Yes, this is also important. So this is how we can have this grid. Okay, two rows and two columns of subplots. This is if we write 2 comma 1, this graph of x versus x, y is equal to x will be plotted, put here. Regarding 2 comma 1, sorry, 2, this another graph of y is equal to x square will be placed here. Then third graph will be, subgraph will be put here. Okay, so this is order. It will start from, start putting graph from uh, top left to top right. Okay, so from top left to top right, and then it will go to bottom left, and then it will continue to bottom right. So this is how we can have this different terminologies. Yes, one more thing which is uh, PyLab. What is PyLab? PyLab is nothing but part of Matplotlib, but it just uses both PyPlot as well as NumPy simultaneously. So we just, as beginner, we just avoid working with PyLab. We will only, in order to have different libraries like PyPlot and Matplotlib, we will use them separately. We will avoid using PyLab. But again, this PyLab and PyPlot are part of Matplotlib. Drawing text, we just skip this, we just skip this. Okay, right. Now we just close these two presentation. One thing I would like to show you is, let me open Google Colab. Professor Maherchan, I'm taking, with your permission, I'm taking, can I take 5 more minutes?
Yes, sir. You can take us 5 minutes more. And
Thank
dear
you very much,
participant,
sir.
please stay connected because some important part is due,
But because,
and
yes,
within
this
five
is, this
minutes
is,
it will be covered.
yes, yes, yes. So first of all, let me import or create one new Google Collab notebook, and let me import that CSV file. Okay. Now I don't know what how to uh, doing programming in Python. So I will use this generate AI. Okay. So I will ask this artificial intelligence, and this, since this Colab is product of Google, Google has its AI, which is Gemini. Okay, so this we are working with Gemini. So let us ask this Gemini import uh, data from this file. Name is this, and if I compile it, sorry, yes, you can see it has written this code, and it is showing me this initial data, but I know a little bit programming. So you can see that my data frame from this CSV file is created. Okay, then let us play with this. I know there are other different start types. So let us ask this artificial intelligence plot uh, plot bar charts of star types. You can see it has given me this code. It is simply required to run this code. You can see that these bar charts are created. Now, these all these charts are having same color. So let us change it. Use different colors. So now you can see that this code is changed now, and you can see that this colors of charts are bar charts are all the bars are changed. Then one another important feature regarding this plot is nowadays, which is very important or and famous, is control plots. Yes. So let us ask this Gemini, please create contour plots, which this contour plot basically does nothing but it just create two-dimensional image of some three-dimensional graph. Of that means let us ask it to create contour plot of z is equal to x square plus y square. So you can see that it has given me this code, and this is contour plot of this z is equal to y square plus x square. Okay. Now I want this dense lines. So I know a little bit programming, and that is why I can identify that if I make this 20 to 200 and if I compile, it will give me more dense contour plot. Okay. So this is how you can use this artificial intelligence in order to have this Python regarding your research. So this is from my side.
Yeah, thank you, sir. Dear participant, the session is open for discussion. If you have further any more question, please feel free to ask from our respected professor. And I hope that we will try to justify your questions if you have.
And I'm first of all, I'm extremely sorry for taking 12 more minutes.
No problem, sir, because the information which you are sharing is very important to all the participants. Time doesn't matter if we have the valuable and productive outputs.
Thank you very
Dear participant, can
Hello.
you please? Yeah,
Yeah,
yes,
I have a question.
yeah,
Hello.
Yes, sir. Yes, sir.
Hello.
yes.
Yes, sir.
Speak.
Hello.
You are audible, sir.
Yeah. I want to ask before we use Google Collapse, is it that
Yes.
we must have what do you call it? We must have Jupyter Notes on our system before we use Google
No,
Collapse,
no,
or
no,
is
no.
all
It is
installed in
not.
the Google Collapse?
No, Google. If you are using Google Colab, you are not required. Even you are not required to install Python, as well as you are not required to install
Jupyter
the Jupyter
Notebook.
Notebook in your system. And all the necessary libraries are already there available in the Google Colab.
Okay. So
Yes.
we can also import the library in Google Collapse, or the
Yes,
libraries are all
we
there.
can. Yes, libraries are there, but in order to use that, we have to import those libraries.
Hmm.
All the libraries for the data analysis and basic scientific computing are available in the Google Colab.
Okay.
And whatever you need for your scientific computing, you need to import before using. And also the files which you
Okay.
will create in collab is Jupyter notebook. Okay, so all the files will be based on Jupyter. Collab is completely based on cloud, and the Jupyter is also itself on cloud. So the all the things which you will create, all type of the file will be in the extension of a Jupyter notebook.
Yes, yes.
Yeah.
And
Okay.
one more thing. The For example, I have created one Jupyter notebook file. Okay, so I can use that Jupyter notebook in my Google Colab. At the same time, the file which we have created in Google Colab can be used in Jupyter notebook. And in
Okay.
99% cases, both the terminologies works.
Okay.
Yes, sir.
Okay.
One more I want to add.
Yes, sir.
If you are working in a team, you can share the file with your team
Yes, yes,
also.
yes.
This is
And that
also
is
very useful.
very much important feature.
Yeah.
That means if you are working with some group, you can share. If you are working with Google Colab, you can share your work with your entire team, and your entire team can contribute. They can see the real time data which you have updated in your Google Colab, and they can use that data and contribute also. Yes, sir.
Any more question, please? I think, sir, best way to learn Python is need to start to work on it.
Work on it.
Yeah.
Yes.
So all the participants are requested. If you are very eager to learn Python, just need to work on it, and there will be all the session will be very supportive. But to start on Python, it's a necessary step from your side. And if you have during these 1 week workshop any question, any problem, please always feel free to ask it, and we will justify your questions. If any more question, please.
Yes. What I can see one interesting question in our chat box. The question is Google Colab reliable in case of we are doing research work aimed at publishing research? Uh, this is an important question. Uh, so to answer this question, see, this is some sort of reliable that cloud storage is somewhat secured of Google, but we cannot completely tension free regarding this data. Okay, so it is, if you are concerned regarding piracy or data stealing, in that case we should avoid using this cloud features. There are chances of leaking of data.
Thank you, sir. And I think all the questions from the participant side has been discussed. And some of are asking about the feedback form. Yes, I am sharing the feedback form in the chat box. You can submit. And yes, so the session was really very interactive and very knowledgeable. Uh, I think Jesse Prajapati sir is also there. Sir, welcome in this session. Yesterday we really miss you during the opening ceremony. So it is my pleasure and honor to deliver the vote of thanks for today's session. First and foremost, I would like to extend my heartfelt gratitude to our esteemed speaker, Dr. R. Panchal, for his insightful and engaging session over the last 2 days. On the day one, Dr. Panchal introduced us the foundation aspect of Python for scientific computing, covering the basic of Python programming, data type, control sequence, and functions. He also walked us through the use of Jupyter Notebook, an incredible tool for interactive computing, which undoubtedly sparked a sense of curiosity and enthusiasm among all the participants. And day second, today, we delve deeper into the world of the data analysis and visualization with Python. Dr. Panchal demonstrated the power of libraries like Pandas and Matplotlib, showcasing how they can be used for data handling and creating meaningful visualization. He also shared exploratory data analysis technique, which will undoubtedly be valuable for our scientific research endeavors using Jupyter Notebook and Google Colab. And also the most important part which you integrate the how we can use AI for the programming in in Google Colab. That is also very important and really very helpful to the beginners, because sometimes we are not able in the beginning what will be the sequence of the programming, and if we have the specific prompt, in that case this AI tool which is integrated in Google Colab will be very helpful to all the participants who are attending this session. Also, Dr. Panchal, your ability to simplify complex concepts and make them relatable is truly commendable. Your session have provided us with the practical knowledge and inspired us to explore Python as a powerful tool in the scientific computing and data analysis. I would like also thank to all the participants to listen very carefully. And as we conclude 2 days, insightful days, I am confident that the knowledge shared will empower all of us to leverage Python effectively in our scientific and analytic pursuit. So once again, I thank you, Dr. Panchal, for sharing your expertise with us. We are truly grateful for your time and efforts. And also, I would like to thank to all the participants for your patience. Thank you to all. And a link for the feedback form I have already shared with you in the chat, and the same will be also available in the WhatsApp group. And
One,
uh,
pardon
I
me,
think
one
all the
small
content
comment.
which we present for you and the Google link we have already shared with you. You can get all the content. Sir, you want to say something?
Yes, yes, sir. I just wanted to say sorry because I just due to time limit, I cannot cover functions which will be very much useful for upcoming lectures.
Sir,
So I request participant to just explore those functions facility of function by themselves, which will be helpful for upcoming speakers.
okay. Thank you, sir, for this information. And dear participant, if you have any challenge or any problem in the future, you can easily contact Dr. R. Panchal, and he will help you. And but you have to share your problem. Only then we are here to support you. So, sir, can you please share the your contact number so
Yes,
that
yes.
if anyone need in a near future any kind of support from your side,
Let
they
me
can contact you.
let me share my email ID.
Okay.
Uh, Maybe I'm not able to. Okay, let me share my screen so that the participants can see my email ID. I hope my screen is visible,
Yes, sir.
and my email ID is Ravi Panchal. This R is small 1712 at gmail.com. Okay, it is Ravi Panchal 1712 at gmail.com.
Thank you, sir.
Yes, thank you very
Thank
much.
you. So now time is about to over, and the meeting is now we ending the session. Thank you. And tomorrow we will resume the next third session at the same time. And the link will be shared at least 30 minutes before the starting the session. Thank you to all. Thank you, sir.
Yes, thank you.
Once again, thank you.